This is the answer key to the January 25th do now / classwork. So we're multiplying 11 times 8 over 11. And when you're multiplying with fractions, everything has to be in fraction form. So 11 is really 11 over 1 times 8 over 11. Now we could multiply across. However, we should look first if there's anything in the numerator and the denominator that we could simplify. Now I noticed that we do have a numerator, 11, and a denominator of 11. Now, if I were to multiply across to get 88 over 11, I'd have to divide 88 divided by 11. But what I could do right away is just notice both 11s can be divided by 11. What's 11 divided by 11? Cross that out, it makes it 1. This 11 divided by 11, cross it out, make it a 1. That's it. So we just do 1 times 8 is 8. Over 1 times 1 is 1. And 8 over 1, which means 8 divided by 1, is 8. And that's the answer to this question. I wanted you to just notice that when the numbers are the same, you just cancel them out, turn it to 11. Stop. Go over the do now, which we just did. Watch the video lesson on module 7.3 and then continue on to slide 3 for the classwork. So at this time, if you have not watched the module 7.3 video lesson, go into the folder and watch it now. So this question, a package weighs 96 ounces. What is the weight of the package in pounds? Use a proportion. So we know proportion means two ratios or rates that equal each other. We take the relationship of pounds and ounces because this, the word problem is comparing pounds and ounces. We know that 1 pound is 16 ounces. So if you look at my work, I put that information on top of each other like that. Put the relationship of pounds to ounces. Now, if you notice on your paper that you wrote 16 ounces over 1 pound, that's fine. But in my problem, I put pounds over ounces. So then when I make my proportion, you write equals. The L for pound, because that's what's missing. That goes on top because I have pounds here on top. 96 ounces goes on the bottom because that's where the ounces go. Now, the package weighs 96 ounces. How many pounds would that be if we know that every pound is 16 ounces? So now let's finish the proportion. 16 times 6 is 96. And I know this because on the side I divided 96 by 16 and saw that equals 6. So 16 times 6 is 96. So I write 1 times 6 is L, the missing amount. So 96 ounce package weighs 6 pounds. The distance from Leah's house to school is 0.5 kilometers. What is this distance in meters? Use a conversion factor. Now, a conversion factor is something we multiply the number by to convert it from kilometers into whatever distance they want you to find. So the question is, what's this distance in meters? That means I have to multiply 0.5 kilometers with something that would cancel the kilometers out and make it turn to meters. Now that one, I want you to go back to that first question, do now. Notice how when the numerator and denominator both have the same number and the numerator and denominator, they cancel each other out. That's something I want you to think of when we do this one, when you're doing conversion factors. Notice how this numerator is in kilometers. So what I'm going to do is I'm going to write kilometers on the bottom. So that I could cancel these labels out. So look at the question. We're comparing kilometers to meters. That means meters would go on top. I'm writing the relationship here, just like I did in this problem. When the question is asking convert pounds to ounces, we write the relationship of pounds over ounces or ounces over pounds. So now we're doing conversion factor. That's multiplying something with 0.5 kilometers so that kilometers is canceled out and it turns to meters. Now I put kilometers on the bottom so they cancel out and it turns to meters. Now, how do I fill in the numbers here? You could look at your reference chart to see what's the relationship of kilometers to meters. And the answer is 1 kilometer is 1,000 meters. So I'll fill it out like this. And now we just multiply. And when you multiply, see if you can simplify anything early. That includes the numbers and the labels. I noticed that I have a numerator kilometers and a denominator kilometers. They cancel each other out, so we're left with just the numbers. Now 0.5 and 1, nothing could happen. So what we just do is multiply across. 0.5 times 1,000. Now I could multiply 1,000 times 5. That's 5,000. And then you count how many zeros. There's 1 0. So you bring the decimal over once. The answer is 500 meters. So that's the answer to question 4, 500 meters. Another shortcut way, without getting rid of the decimals and multiplying that, when you have a number like 0.5 and I multiply it by a power of 10, like 1,000. 1,000 has 3 zeros. Move this decimal 3 to the right. 1, 2, 3. So I took that decimal and I moved it 3 to the right, and it becomes 500. So that's another way you could multiply that without getting rid of the decimal and then putting it back in. An African elephant weighs 6 tons. What is the weight of the elephant in pounds? Use a conversion factor. So hopefully this one's a little easier. Remember with this one, if kilometers on top, kilometers has to be on the bottom. And then put the other information on top. So let's look here. We want to use conversion factor. We're comparing tons and pounds. So would I put tons on top or on the bottom? Hopefully you said on the bottom because we want to cancel it out. So I'll put tons on the bottom and then pounds will go on top. And the abbreviation for pounds is LB. Now, what's the relationship of tons and pounds? 1 ton is 2,000 pounds. So because it's 1 ton, I could erase the 0. You don't have to have it there. Now I want to simplify my problem. I noticed I have a numerator, tons, and a denominator, ton, and they cancel each other out and turn to 1, but you could just cancel them out. And then we could just multiply to get the answer because there's nothing you could simplify early. 6 times 2,000 is 12,000 over 1, which is just 12,000. So the answer is 6 tons equals 12,000 pounds. Now, putting a comma there, feel free to go back and try any of these problems again.